Okay, today we'll talk about the second order homogeneous differential equation. We mentioned before how what kind of process you should follow in order to use the exponential guess method to reach your solution. In the exponential guess method, we mentioned what to do when you have distinct roots and what to do when you have repeated roots. And today we will talk about the methodology you should follow in the exponential guess when you have complex roots. As you remember before, when you look at your second order homogeneous differential equation that will end up and equalize to 0, then you have two factors that you care about in the equation. The factor of y, which is a, and the third term factor, which is b. Firstly, you want to verify, is your equation having distinct roots, complex roots, or repeated roots? And we said that can be done by the verification method of having a squared minus 4 multiplied by b. Then you're gonna see if it's equal 0, then you have distinct roots. If it is above 0, then you have repeated roots. If it is under 0, then that means you have complex roots. Then the moment you have complex roots, of course, as we mentioned before, you changed all your y's into lambdas. Like, let's say you have y squared plus a y plus b equals 0. That's a typical second order homogeneous differential equation. So this is your a, this is your b. Now you plug your values of a and b in here in this equation, then you can decide what you have. If you have complex roots, then most likely you will have your first root as the following form. Lambda 1 would be equal to alpha plus I multiplied by beta, and lambda 2, it will be alpha minus I multiplied by beta. Then your general solution would be something like y equal to e to the power of alpha x multiplied by c1 cosine beta of x plus c2 multiplied by sine beta x. And you will be good to go. The solution will be as simple as that. Now, let's take an example and try to apply what we learned moments ago. So you have an equation, y double prime. Oh, let's go back here. I don't mean square here, I mean second order double prime. Okay, y double prime plus 2y prime plus 3y equals 0. In this case, this is your a and this is your b. Now, applying what we learned before, here y prime and here's y, sorry about that. Now we want to see what kind of equation we're trying to solve. So we're saying a squared minus 4b in here. So a squared is like 2 squared minus 4 multiplied by 3, in this case, equals what? 4 minus 12 equals minus 8, which is less than 0. So we're expecting to have complex roots. Okay, coming back to the equation, we are having here y double prime. In this case we can represent it as lambda squared plus 2 lambda plus 3 equal 0. Now, solving for this second order equation, lambda 1 would be minus 1 plus I square root of 2, and lambda 2 will be equal to minus 1 minus I to the square root of 2. Okay, our general solution using the general form that we wrote up here, the general solution for this equation would be, firstly recognize alpha and beta. In this case, minus 1 is alpha and square root of 2 is the beta. So y equal e to the power of alpha, which is minus 1 multiplied by x, all multiplied by c1 cosine beta, in this case the square root of 2 multiplied by x, plus c2 sine beta, the square root of 2 multiplied by x. And this is the general solution for our equation. And in this way we learned how to solve for complex roots using exponential guess method for a second order homogeneous differential equation.